Hi there, this is the first look at exercise 7B, more statistics. Looking again at these random variables, continuous random variables, where effectively we get a formula which describes the probability over a range of values for x. And this is one such example. For instance, we've got the random variable for x described as f of x equals half of x. And so that effectively gives me a straight line on this one going from obviously the origin. And if you put x equal to 2 into this, a half of 2 is 1. So that's why here it goes up to 1. And obviously if I put 1 in, half of 1 is half, so that's a half. So you can see this is a straight line graph. What we're trying to do today is to find the median and also the quartiles and the mode of these types of graphs, and they all have definitions. And this actually, you can see this first one, it represents the median. And so what it's doing is it's saying the median, which I'm calling m, will be the place, the x value, where to the left of it you have exactly 0.5 for a probability, but also to the right of it you also have 0.5 for a probability. And it won't necessarily be in the middle of 0 up to 2, because you can see it's a triangle, and therefore it's not sort of that size of area is not as big as this bit over here, which is much higher. So you've got to take that into account. So the way we deal with this is integration. So let's show you. This says the median and the quartiles, just missed off the top. We need to be able to find the median then and the quartiles, and we're going to use integration to do it. And also this idea of m. I'll show you, probably easiest if I show you. So here's our example. It's properly defined as f of x is half of x between 0 and 2. Beyond 2 it doesn't exist. So I suppose it's 0 initially, it goes up this line and then it carries on here. And some people like to see those extra bits of line. But the way we're going to do it effectively is we're going to say, well, if I integrate, someone's emailing me, if I integrate half of x between, well, the start point was 0, so I always start on 0, and I go up to what I'm going to say is my median. So I'm going to go up to m, and if I integrate that, I want to equal a half, because I want half of it to be to the left of this point, up to this point. And so that's what I'm trying to find. I'm trying to find the value of m that will do that for me. So if I integrate that, it's a half x squared over 2, add the power divided by the power, between 0 and m. And that obviously is a quarter x squared. And if I put 0 and m in, it doesn't surprise you to learn, well, m goes in quite happily, a quarter of m squared, and it's not always the case, but in this case you put 0 in, you get 0 out. So I don't need to worry about putting 0 in, but that equals a half. Move that over, I get m squared equals 4 over 2, which is 2, and therefore m equals root 2, or if you prefer 1.41 as a decimal. And it's definitely the positive, because you can see it doesn't exist in the negative, so we don't have to worry about is it plus or minus. There's my answer, m equals 1.41. So that's the process we're going to use to find the median. And given properly, a is the starting point, which in our example was 0, so I didn't have to worry about it. Going up to m, the integration equals a half. And it won't surprise you also to learn, if I want the lower quartile, I go from a up to the lower quartile, and it has to equal a quarter. But if I want the upper quartile, which we use a capital Q for, a up to the capital Q has got to equal 3/4. So it's quite straightforward to find the median and the lower and upper quartiles. So here's another example. A continuous random variable has probability for, so now this, well, if you multiply that, that would actually be a cubic graph. You've got graphical calculators, so when it says sketch the graph, you can quite easily do that. You might even suss that this is 1 plus x, 1 minus x. So I know that if I was to draw, now I know it's not going to be like this, but if I was to draw the graph as if it had full range of values for x, it would cross at x is 0 because of this first bit. It would cross at minus 1 because of that one. And it'd cross at plus 1 because of that one. And interestingly, because of if you was to multiply this out, you'd get minus 4x cubed as your highest power. It's negative. So rather than going up and then down and up, it goes down and then up and then down. Now, of course, R's only exists between 0 and 1. So when it says sketch the graph, that's the only bit I'm after. So if I was doing this, I would go, it basically does that to that between 0 and 1. That's my graph. But I also try to show this. And I'd write f of x up here. And I'd write x here. That's my graph. Find the median. Well, is it straightforward? Oh yeah, fairly. Let's multiply this out. I didn't do it before, but it becomes 4x minus 4x cubed when I multiply it out. So I'm going to integrate 4x minus 4x cubed. I want the median, so I go from the start point, which is 0, up to m dx, and that has got to equal a half. So let's integrate that. I get 2x squared when I divide by the 2. I get x to the 4. That's quite nicely done, isn't it? Between 0 and m equals a half. Again, if I put 0 into this, it will disappear. So the only thing I'm going to get is 2m squared minus m to the 4 equals a half. And I'd probably just say, look, this is really the sky's quadratic. Move that over there. Minus 2m squared plus a half equals 0. So this, if this is the sky's quadratic, I can chuck it into my calculator. Menu I want a polynomial degree 2. So I've got 1x squared negative 2x 0.5. And it says rather horribly that, well, x equals, and therefore m squared equals 2 plus root 2 over 2. Now, I think it's probably too big that. If I did that, I'd get, well, this is 1.41, 3.41 divided by 2 is 1.7. That's too big. So I think it's the second answer I need. Or actually, maybe not, because I'm going to square root it anyway. So I'll just write for the moment plus or minus. And when I square root it, because that's m squared, so I need the square root of that. So I'm just going to write now mode 1. So it's 2 plus root 2, all divided by 2. And I've got to find the square root of that number. And I get, no, it was too big. This is 1.307 or something, which is too big. This one, 2 minus root 2 divided by 2. And I'm going to square root that up, and I get 0.54. 541 to be precise. So this is too big. So you know, so I'll just make a note. Has to be greater, less than or equal to 1, and it's not. So no solution. This one is okay. Let's see what the answers actually say. That was the graph, so that, well, mine's better than that graph, because you can see this graph implies it carries on going forever. 541 is the answer. Good. Next question, it says a continuous random variable has that probability density function. This PDF thing, it's just another posh way of saying, you know, the formula is. Now it's only valid for x is bigger than or equal to 16. Now, I haven't got a clue what that is. If I chuck this into my calculator, this is it. I actually took this from either the textbook or the exam paper. I took the exam question from, I can't remember which one. But you can see then it going from 16 up to x, this is the curve they want. But they also want to see that part. And it goes, you can see it almost goes that bit as well. And it only becomes a proper thing after 16. Okay? Now at some point beyond this, this area here equals this area here. I don't know exactly where, that's why we call it m. So to find the median, we do the integral of 2560 x to the minus 7 over 2, starting at 16 and going up to some magical number m. dx, and that equals a half. So okay, let's do that. And now I've got to add a power, so I reckon I get 2560. That's to the minus 7 over 2, so I reckon it's x to the minus 5 over 2. So I've then got to divide by minus 5 over 2. So 2560, what's that? 2560 divided by minus 2.5, which is what that is. And I get minus 1024, x to the minus 5 over 2 between 16 and m equals a half. Now obviously I put the m in, minus 1024 m to the minus 5 over 2. But now I've got to put the 16 in, and that will give me a proper answer. So what is it? Minus 1024 times by 16 to the power of negative 2.5, or minus 5 over 2. And I get minus 1. Well, there you go. So it becomes minus a minus 1. And that equals a half. So when that's plus a half. When I move over, it'll become a minus a half. But it's a minus and there's a minus there, so I can ignore those. So m to the minus 5 over 2 is a half divided by 1024, which is obviously 1 over 2048. It just goes on the bottom. And now I do the inverse of that, and m therefore is 1 over 2048 to the power of minus 2/5, because when it moves over that changes, it becomes a reciprocal. So let's do that. 1 divided by 2048, and it's to the power of minus 2/5. And I get 21.1. No idea if that's right. There it is. Now the quartiles, it's broadly the same process. Let me just do it. To find the lower quartile, you remember, we call little q, and the upper quartile we call big Q. So I'm just going to do the, let's do the lower quartile first. The integral from 16, because that's our start point, you remember, up to little q of the same 2560 x to the minus 7 over 2 dx is now equal to a quarter. So it's very, very similar to just now. So let's just go back. If you remember, when we iterated, we got this. So I don't intend to do much more work to that. Let's just do that now. It's minus 1024 x to the minus 5 over 2, now between 16 and q, equals a quarter. So when I put that in, I get minus 1024 x to the minus q, to the minus 5 over 2. And I remember this being minus 1 from memory. Let's just check that. I don't want to get that wrong. It was minus a minus 1. That was right, which is a plus 1. But now it's equal to a quarter. So it just changes my equation. So now I get, move that over, that's plus 1, plus the quarter that's already there. Gives me 5 over 4. What was it last time? How did that work? It was plus 1, and I moved it over. That gave me minus 1. That's right. So here the plus 1 moves it over. All right, yes, it's minus 1024 q to the minus 5 over 2. And that's a plus 1 there. So when it moves, it becomes a minus 1. So it actually gives me minus 3/4. And as I said last time, you can make the minuses both equal to pluses. And now really it's q to the minus 5 over 2 equals, let's just do it again, it's 3/4 divided by 1024, which says 3 over 4096, and therefore the q is this number to the power of minus 2/5. So let's do it to the power of minus 2/5, and I get 17.95. To do the other one, I'm going to do exactly the same thing. It's now integral from 16 to big Q for the upper quartile of 2560 x to the minus 7 over 2 dx. But now, of course, because it's upper quarter, it's equal to 3/4. and on that basis I get minus 1024. You can see everything changes just very slightly. For instance, all this stuff is exactly the same. Now written with a capital Q, but now equal to 3/4. And when I chuck this in, I get minus 1024 to the minus 502 plus 1 equals 3/4. And when I move that over, then I get minus 1/4. And when that becomes plus, you can see all that's happened. The 1000 comes over here, and I end up with, oh, I missed out my Q there, capital Q. I end up with Q to the minus 5/2 equals 1/4096, I think. So when I do that, Q then is 1 divided by 4096 to the power of minus 2/5. And I get 27.86 I get. So if I rounded those, 27.9, 18.0, yeah, you can see they work. And to be told that the median is roughly 18, yeah, quite probably. The lower quartile was there. The median, what was that? I'm just trying to remember what it was on the last question. It was 21-ish. 21-ish. And then the upper one was 28-ish. Where's 28? Well, about there, perhaps. Seems quite reasonable. That was the upper quartile. So, let's do this next question, the mode of a PDF. Now, we've not mentioned the mode before. You can actually do this just from the sketch, and it'd be quite hard to do it any other way, really, without doing lots of different sums. The continuous random variable x as probability density function this, and you can see all it is a posh quadratic. Here's the sketch, and you can see it goes from there. Well, presumably I could work that out. It would be the y-intercept would be 3/50 times 5, which I think is 0.3. It makes sense that it is. Just check. Ooh. Oh, 0.18. Have I typed it in right? 3 times 5 equals, yes. 0.3, I was right first time when I did it in my head. You see, it just goes to show you can trust your brain more than your calculator. So anyway, that goes up to 0.3. And it's important to know that, because the other thing you notice is over here, it looks to me as if that's higher, just from the graph. And so I think I need to chuck 5 in. So I'm going to do exactly the same thing, but this time I'm going to chuck 5 in. So 3 divided by 50 times by, in brackets, 5 squared minus 4 times 5 plus 5. And that gives me 3/5, so that's 0.6. So just by looking at this graph, you can see the highest point is there. Because you know a quadratic, which this is, just it's not going to do anything funny in between. So therefore the mode is simply 0.6. That was rubbish. The mode, that's terrible. The mode has a value or a height of 0.6. The place where it happens is 5. That's a much better answer. Nearly fell for a bad mistake. So 0.6 tells me that's the highest value, but the place where it happens is at 5. Ooh, very nearly bad mistake. Keep on going then. A continuous random variable has this. Oh, this looks like the one we saw before, isn't it? This is the same question as we saw before in terms of the function. The same graph. Now again, I've already taught you that really we should be drawing it like that, and we should not have this bit underneath the curve, because it's only valid between 0 and 1. And actually we've also already said that a PDF of this fx graph can never ever be negative. So there, up, and then 0 again. That's the graph. So we'll find the mode. Well, I suppose to find the mode, it's tempting to think it's in the middle, but on the graph it's not really in the middle, is it? It seems to be slightly to the right of the middle. How am I going to do it? Well, probably a bit of differentiation. That's really saying, when is that a maximum? When has that got a maximum value? And so this highlights the fact that we can use differentiation to do it. We know, for instance, f of x ignore the naught bit, it equals 4x minus 4x cubed. So therefore f dash of x, well, differentiate, lose the power, and times 4 minus 12x squared. And you get turning points, stationary points, when it's equal to 0. So I can say 12x squared equals 4, x squared is a third, and x equals the square root of a third. Or, I suppose, the square root of 1 over the square root of 3. And you can actually write that, if you type that into your calculator, it doesn't matter how you get there, it's root 3 over 3. Okay. What's that as a decimal? It's about 0.5, I think. So root 3 divided by 3 is 0.192. There you go. If I typed it in right. Root 3, no, I haven't. I typed it in wrong. Getting my 0.577. So actually, my brain worked better than my calculator skills. 0.577, what have I got here? The mode is 0.577. But interestingly there, you can see just by the graph that's a maximum point. I suppose there's an argument for saying, how do you know? You could find the double differential and things like that, but I'm not going to bother here. It says find it, I found it. Okay. So your job, exercise 7B. Now again, I've only taught you how to do question 1 really. Question 1 says find the median and the mode for each PDF. So if I ask you to do anything else, I can't remember what it says. It might, for instance, say find the expectation, find the mean. Don't do that. All you're doing is find the median and the mode for each PDF in the first column. And if there's more questions and you want to do more, let's say in the second column, feel free to do those as well. Best of luck. All the best.